Today, we're digging into one single component that lets the toughest vehicles on the planet handle unbelievable amounts of power. We're talking about the Hypoid gear. It's a true engineering marvel that's probably hiding in your own drivetrain.
So, have you ever wondered how a massive truck or a rugged off-roader can put down so much torque without just, well, tearing itself to pieces? The secret, it turns out, is hiding deep inside the differential. And here it is. This is the Hypoid gear set. Now, at first glance, it might look like other gears you've seen, but its incredible strength comes from one very specific, very clever design feature, the offset.
Okay, so let's really focus in on this gear offset, because this one single design choice, this tiny shift, is where all the magic begins. It's the foundation for everything that makes these gears so incredibly strong.
This slide shows it perfectly. Just look at the comparison. On the left, you've got a standard spiral bevel gear. See how the pinion shaft lines up directly with the center of the ring here? Their axes intersect. But now look at the Hypoid gear on the right. The pinion shaft has dropped down. Its axis is offset, meaning they never actually cross.
So let's nail down that definition. The axis offset is simply the shortest distance between those two shafts that don't intersect. It seems like such a small tweak, right? But that single change completely transforms how the gear teeth engage with each other, and that's what unlocks this massive increase in strength.
And that little tweak leads us to the next big idea. Because of that offset, Hypoid gears are actually engineered to slide. And I really want you to get this. This is not a bug or a design flaw. It's the core feature that gives them all their power.
Let's break that down a bit. With a standard bevel gear, the teeth mostly just roll over each other. The contact happens along a pretty simple line. But a Hypoid gear? It's a whole different ballgame. The motion is a combination of both rolling and sliding. The contact point actually sweeps diagonally across the entire face of the tooth.
So you might be asking, why does it slide? Well, it's really three things working together. First, that pinion is on an offset axis. Second, the gear teeth themselves aren't simple cone shapes. They're complex 3D curves called hyperboloids. And third, because of that geometry, the two mating teeth are actually moving at different speeds right at the point where they touch. That difference in speed is the sliding action. All right, let's connect the dots. How does this engineered sliding actually translate to better performance out in the real world? This is where we see why this technology is so crucial for the machines we rely on every day. You know, everything in engineering is a trade-off, and this slide shows it brilliantly. The advantages are massive. That sliding action gives you a much larger contact area on the teeth, which means way higher torque capacity and a much smoother, quieter operation. So what's the cost? Well, you get more friction and heat, a tiny drop in efficiency, and you absolutely have to use a very special kind of lubricant. And here's the thing. For any heavy-duty use, those advantages are completely non-negotiable. When you need to transfer a ton of power to the wheels, you gladly accept those trade-offs. This incredible strength is exactly why these gears are essential in the differentials of the world's most rugged vehicles. I mean, think about it. A Toyota Land Cruiser climbing over rocks, or a Mitsubishi Pajero clawing its way through deep mud. Their differentials depend on Hypoid gears to deliver that power without failing. And it's the same story for big commercial trucks and excavators, where the loads they handle are just absolutely massive. Okay, this brings us to a topic that is absolutely critical. All that strength, all that sliding, it all comes with one very strict rule. We have to talk about lubrication. It's the unsung hero that keeps these powerful gears from destroying themselves. So how does this work? That intense sliding action generates some serious heat and pressure. This is where a special gear oil, rated GL5, comes into play. It's filled with what are called extreme pressure, or EP additives. These additives literally react with the hot surface of the gear teeth and form a microscopic sacrificial film. This tiny layer prevents the raw metal from ever grinding directly against raw metal, which would be catastrophic. And I really can't stress this enough. This is a serious workshop-level warning. If you put the wrong oil, like a standard GL4, into a differential with Hypoid gears, it's a recipe for total disaster. Without those special EP additives, the gears will chew themselves up and fail in a hurry. So, how do you know if something's going wrong with yours? Let's talk about some practical diagnostics. A differential will usually give you some warning signs. You just have to know what to listen for. The classic symptom is a whining noise, one that changes pitch as you speed up or slow down. You might also hear a clunk when you shift from drive to reverse,
Or notice that the differential housing itself is getting way too hot to touch. And of course, if you were to open it up, you'd see physical damage, pitting and scoring on the gear teeth. And 9 times out of 10, the root cause is either the wrong oil or an incorrect gear setup.
Now that we've got the basics down, let's just geek out for a minute and take a quick look from an engineer's point of view to really appreciate the design challenges here.
One of the key things engineers have to manage is something called sliding velocity. That's just a fancy term for that speed difference we talked about between the teeth. The real art of the design is finding that perfect sweet spot, getting enough sliding contact for maximum strength without creating so much heat and friction that the whole thing fails. It's a real balancing act.
And the secret to controlling that sliding velocity? It's all in perfecting these hyperboloid pitch surfaces. Remember we said they weren't simple cones? It's this incredibly complex 3D geometry that allows the teeth to mesh so smoothly and spread the load out, making that powerful, controlled sliding motion possible in the first place. And really, this quote from the source material just says it all perfectly. It is a controlled and engineered sliding motion, not a defect, and is the reason modern automotive differentials can handle extremely high torque loads reliably. That's the key takeaway. So, next time you see a big truck pulling a heavy load or a serious off-road rig on the trail, you'll know the secret that's hiding inside its drivetrain. It's not just a bunch of gears, it's a masterpiece of controlled friction, built to slide and engineered to be unbelievably strong. Will you ever look at a differential the same way again? I doubt it.